Simulation and emulation. Let's start with a definition. So Polytron primarily uses simulation on the front end engineering of activities that we work on our projects. And we look at that definition as any model, right? It doesn't matter what type of model that has embedded controls that allows you to further refine and design the system that you're putting together, right? And if it provides a predicted operational output, throughput, that's even better, right? But the tool is to help you define the options that are available and narrow those options down from the front end design. And so we're going to focus the next session on that. Emulation is what we do on the back end. If we can take that model that we've created through whatever tools and mechanisms, and we can layer the control system on top of that model and actually run that virtually, we now open the door up to virtual commissioning, training, and doing some design of experiments that will not only improve the design through the design process, but validate the approach and provide a lower risk profile for system startup and commissioning in the back end. And we'll cover that in the second portion of our case study. So these are the value propositions that we see for simulation. You may have different value propositions for your business, but these are what we see primarily with our customers. And that is, we primarily lower the investment risk. We reduce the risk associated with spending time on designs that may not be the optimal design on the front end. And we provide higher confidence on the output of what that throughput or that OEE is going to look like on the back end by doing simulation on the front end. The other thing is the process of just developing a simulation model requires people to be very focused on the data, how the system functions, what those performances are, and it allows people to bring in more insight as to what they're trying to accomplish in any project, whether it's full automation, packaging, or process. It's the same process approach. Many times it'll offer a need for us to audit an existing system, and that'll bring in new ideas that customers have not heretofore seen within their own system, limitations, things that are pinch points, things that are preventing them from optimizing their existing systems. And once we get all that on paper, or we put it within a model, regardless of the software, it allows for a quantitative evaluation of design options. And so this allows many people within our customers' organizations to look at the data objectively and say, this is better than that in terms of an option, regardless of whatever profile they come from, whether their background, whether it's operational maintenance or engineering. They now have a tool with which they can all speak together around what's the best choice to move forward. And the level of design can be managed based on how much risk you want to take and how much you want to manage on the front end. So the opportunity we have today with a bunch of new design tools is to tailor the amount of front-end engineering and simulation you do to the amount of risk you're willing to take on a particular project. And so this graph kind of shows that. Early on, a lot of simulation has been around for a long time. So a lot of times early on, spreadsheet models, flow sheet models, these are things like FlexSims, MATLabs, Arena, those things that take a mathematical model and then align them with relationships to each other and other object-oriented activities to come up with a model, a mathematical model that would provide some sort of output and allow you to make decisions and make around the design choices you're trying to make. As you go up the tree and the amount of time it takes to develop those models, you get to 3D modeling, which now allows things like Simio, SolidWorks, Sim 3D, those models that bring in actual layouts, physics, right? Sizes. Now we can talk about capacities and throughputs. And then as you get deeper into that modeling space, you can start adding first order physics into those models. So now we can start talking about the first order effects of heat exchangers for shell and tube or plate and frame, and actually get a better understanding for that simulation model, what's going to be the output on the back end of that model that you can make some decisions around. And as you go higher up the curve, you eventually get into product lifecycle management, Siemens software, the PTC type software that is going to look towards people that are manufacturing parts and pieces and track that design part all the way through the life cycle, back through reliability and quality and all the way down to your ERM. That's not the space that we're talking about today. So that's off the sheet, which is why it's off the sheet on this. We kind of play in the space as an integrator. We're managing technologies that are off the shelf. We're putting together units of operations to create better systems. And so for us, the opportunity for simulation that's offered today is, as these new order tools, the 3D models become cheaper, we can now put a 3D scan on an existing brownfield site and create a model in about half the time we used to be able to do that, right? As those tools become more and more available, lower cost, we're allowed to bring those tools into the front end of our design a lot quicker, better, faster with regards to food and beverage consumer products. And so we're taking advantage of that. Simulation